2 today, and we're going to look at solving equations algebraically and graphically. So the algebraically part won't be new. The only new part is we'll have some lucky fractions involved. And then I'm going to show you how to solve equations in your calculator. So that may or may not be new to you depending on what you did in algebra 2. So we're going to solve equations both algebraically and graphically. I have some linear equations up here, which it should be good news. It means we've done these before at some point. I just made them nasty. They just had fractions in them. So let's start by hand, and then we'll do these in the calculator. By hand, does anyone have any ideas on some way we could solve that equation on all that? Okay, got a common denominator? Could you do that? That one option. Is it the only option? So let's common denominator, if you do that. This one would need a multiply by 4, and this would need a 5. And so we would get 4x minus 5x over 20 equals 7 over 20. And at this point, you could cross multiply. You could completely ignore the denominator since they're both 20. Now you've got a lot of options. What would y'all do? We could just say, well, 4x minus 5x would have to equal 7. And so if negative x would equal 7, or x would equal 6. So that's option 1. Bailey's way. First grade. How many of you are really bad at common denominators and fractions as well? Okay, so let's look at another option. Still algebraically for now, and then I'll show you the third option, which is the calculator. Isn't x over the 5 the same as 1/5 x? And isn't x over 4 the same as 1/4 x? Everyone agree? A lot of times we get really weirded out that these are fractions and think that we have to do this problem a different way than we do every other linear equation. If this was any other linear equation, wouldn't we just combine the x's on the left? If you are horrible at fractions, in this class we will never take your calculator away. Can your calculator do 1/5 minus 1/4? Good. 1/5 minus 1/4. So x over 5 is the same as 1/5 minus 75. Option 2. I like your way. You already get the denominators. Works great. A lot of people can't do that. So what is 1/5 minus 1/4? Math enter. There we go, math enter question I'm talking about. Try it. It'll give you a fraction. Negative 1/20. Is that 7? Sorry, it was 7. And then in normal solving fashion, how would you get x by itself? Divide by negative 1/20th? And you still do that. So your calculator divide fractions.
Yeah.
It's pretty good at that. So, I just wanted to show you, you have multiple options for this. Don't let yourself get stuck. So negative or 7/20 divided by negative 1/20 is negative 7 in your calculator. When you divide fractions, you flip and multiply. That's where they get the negative 7 at. Okay, so those are 2 by hand options. I'm going to show you a calculator option in just a moment. Before I do, I'm going to go do the other problem. And come back and do this in the calculator. Any questions? number 1 on the last problem. How many of you preferred option number 2? You have those exact same options for this problem. I can get a common denominator with a 3, 4, and a 1 if I want to, and then do option 1. Or I can do the exact same thing I did on option 2. It's up to you, however you want to do that. I'm going to start with the option 2 first. This would be 1/2 x, or let's not even simplify that. It was 2/4 x. Everyone agree? That would be 2/4 x minus 3/4 equals 1/3 x plus 1. Any questions so far? And then what would you do to solve? Good. Get all the x's on the same side. Doesn't this feel like something we've done before? It just has some yucky fractions in it. Other than that, you have done this before. And remember, your calculator can compensate for any fraction, addition, subtraction, multiplication, division that we can't do. Your calculator can do that. So I'm going to do minus 1/3 x. I think that's a little 7. That's it. Something like that. 2/4 minus 1/3 in your calculator. Math enter, and it will take care of the common denominator for you. Is it 1/6? So I get 1/6 x minus 3/4 equals 1. And then what would I do? Add 3/4 over. Again, your calculator will take care of 1 plus 3/4. Just push that in there, and it will take care of that. You get 7/4. Is that what it says? And then divide by a 6th or multiply by 6, whichever one everyone following how to do this. Divide by 1/6 again, or if you would rather think of it as multiplying by 6, you could. And so you get 22. And you can leave the answer like that. I would also accept 10.5. So either way. Any questions about that one? And I'm going to show you how to use a calculator. There are a lot of different algebraic ways to solve it. I kind of wanted to come stick with what you already know how to do. So we're sticking with that. But any option you have, if you already are good at common denominators and whatnot, go for it. You can do whatever you want as long as you're getting the right answer. So get a calculator out for me. And this may be a new skill for you. May not be, I don't know. Does everyone have the 2 original equations written down so that when I pull the calculator screen up, you'll know what I'm doing? In your calculator, in the graph in your calculator, you can solve any equation that you would encounter in at a high school level that has all numbers in it. Now, if it has multiple variables, that's where our calculator will start to fail us. But anything that has just numbers in it, our calculator can solve everything. We just have to learn how to work it. So what I'm going to do is in y1, I'm going to put the left-hand side of the equation. So I'm going to start with that first equation, and I'm going to type x/5 minus x/4. And then in y2, I'm going to put 7/20, the other side of the equation. Okay. Everyone see what I'm doing so far? That's going to graph 2 lines. 7/20 will be a horizontal line, and then x/5 minus x/4 will be some kind of slanted line. We know from the work we did Bailey's way that that'll be a line with a slope of a 20th, I think, something like that. So we're going to graph that. Notice I have a hard time seeing anything, right? My windows, it's probably -10 to 10. Actually, it looks like something farther left. But it looks like maybe if I zoom in on my y-axis a little more, I can see better. So I'm going to go to Window, don't just push Zoom, and I'm going to change my y-min to be a smaller number, like -5 to 5. You may even want to go farther than that. What I'm looking for is where these two lines cross. Do you see it? Do you see where they cross? Everyone see that intersection? Right here we have, I'm going to actually go a little farther in just so you can see it a little better. You would not have to do this. But. So there's my slanted line and there's my horizontal line, and you can see where they intersect. That is the solution. That's the answer to that equation. So what you're going to do is go to Second, Trace, and a menu comes up. I want to find an intersection, correct? So which button do you think I would push? Number 5. And it says first curve, question mark. It's asking you a question. Well, as long as you're on one of the two lines, you'll push enter. Then it says second curve, question mark. You're on the other line, you'll push enter. And then you'll get close to the intersection and push enter one more time. If there's only one intersection, you could skip the last step. And it gives you x equals -7. Does that sound familiar? That's the solution to the equation that we got by hand, isn't it? So, using the intersection button can solve any equation graphically.
How do you get the intersection?
Push enter. Push enter. And get close to the intersection and push enter again. Move your cursor over to close to the intersection and push enter again. Did everyone successfully do that? Try the other one. Try the other equation. I want to see if you can do the other one. How many of you knew about this skill before this class? Yeah, a couple of you. The rest of you, this is brand new too. So if you're on the ACT and there's some exponential equation or logarithmic equation that you don't know how to solve yet, what can you do? You can do this for any equation, not just linear. Okay, does everyone have this typed in? Something like it. You might have used a fraction bar on the x. Yes. And that's the answer you will get if you're using the graphing screen. But if you ever decided you wanted to make that a fraction, Kyle, you can go in your home screen and type 10.5 math enter, and it will change it. Yes, it is. I would say that when you are using the calculator,
Just do it like
doing it like this would avoid any errors that you might make algebraically, but of course any equivalent form of the equation is going to give you the same answer. Okay, go to graph. I see one of those lines coming up and I see the other line coming up, but my window is really zoomed in, isn't it? Where does it look like those will intersect? Up here somewhere, right? Way up here somewhere. Everyone agree? So I need to change my window and make my Y-max bigger. Remember, my Y-max right now is only on 2 because I shrunk my window to see the other one. I'm going to do 15 maybe. I think I was successful on the Y-max, but maybe not on the X-max. Does everyone see how it might be a little bit to the right? Which brings me to a mental note. Is solving in the calculator a fix-all? What could you see coming up as a problem in the calculator? Having a hard time finding the intersection in your window. So this works great if it's an easy window to find, but keep in mind that there may be issues with that. Not right now, unless it's an absolute emergency. Is it? Okay, but next time, try not to let that happen in the middle of a line. Okay. And now second trace 5, enter, enter, enter. And you get 10.5 for your X, which makes sense.
I did that.
Let me see your calculator. The original equation had a 4. 2x minus 3 over 4.
Oh, it's 3 over 2.
Any questions? I got 10.5. And that is actually the only part that matters, is the X value. Because you're trying to solve for X. Any questions about solving in the calculator or solving by hand? It is awesome to have both skills, right? That way, if by hand fails us, we can go use the calculator. If the calculator fails us because we can't fit the window, we can go use by hand, whatever way works best. Did you ever move your window out to the right? Okay, let me, teaching moment. When Lily did this, when she went to second trace 5 and she tried enter, 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 it said error, no sign change. That does not mean there's no intersection necessarily, but it does mean there's no intersection on your picture here. And so what she didn't do is change the window. She still has the X max at 10. Well, we know the answer is 10.5. So she can't quite see the intersection, and that's what I mean by the calculator can fail you if you can't get that intersection in the window. But if you look, it looks like it's just a little bit to the right. So I just can't quite see it because it's a little to the right. So I'm going to go and just make my X max bigger a little bit. So, and then now it will show up. So you do have to fit the intersection in the window for it to show up. Okay, so we actually already did both of these problems. So the graphs are what we got on the calculator. We can sketch them if we want to. But what I really want you to know is solving graphically. There's 2 ways you can do it. This is not how I showed you so far, but I'm about to show you this way also. One way is to put one side in Y1 and one side in Y2 and find the intersection. The other option is to get 0 on one side first. Let me show you that option. I'm going to do that first equation. How would I get 0 on one side? What would be the most efficient way to get 0 on one side? Subtract 7 over 20. So if I do that, if I get 0 on one side, I would have x over 5 minus x over 4 minus 7 over 20. And I could graph that line. I'm going to zoom back to a standard window. Oops. It is a hard line to see because it's really small. You remember last time we looked at this one, we did our y's from -2 to 2. Now, wouldn't I be looking for where this crosses the x-axis? So there's another button you can use. Second trace 0. To do the zeros, you have to find where it crosses the x-axis, which is right here. And you have to go to the left of that. I'm cheating a little. We do know the answer is -7, but I do need to go to the left of -7. I need to get on the other side of that 0, push enter. Then it says right bound, question mark. So it needs you to go to the right of the 0 and push enter. And then push enter one more time. You get -7, 0, right? Now, what's the perk of this method over the one on the first screen? You kind of know where your answer is going to be. It's going to be on the x-axis because you know it's going to cross the x-axis. So another calculator option. So I'm giving you lots of options of different ways to find these answers. So you can get 0 on one side and graph it and find the x-intercept. If the right-left is hard for you, I do want to show you one other thing. Hopefully I'm not going to overload your brains. You could also put 0 in y2 once you've got 0 on one side, and you could still do an intersection. If you don't like the left-right button, you could do second trace intersect, and it will give you that intersection if you put 0 in y2. So a couple of different calculator buttons you can use to find those intersections. So you can put it equal to 0 and put it in the calculator, or you can do both sides in the calculator. Either way works. Again, the one perk to getting 0 on one side is then you're looking on the y-axis. You still have to find your x window, but the y window just needs to include the y-axis, so it makes it a little easier to set the window. Okay, now we're going to talk algebraically, solving equations. This is our last slide. So we've already talked about algebraically solving equations. We've now proven it. Now we're going to look at solving equations. Do you ever remember seeing some of these on ACT? We'll say, what times t? Or what is an expression that represents t? Or something like that. And it'll have an equation that it really just wants you to get t by itself. So we're going to do that. Anytime you are solving an equation, your process is to undo things, right? Try to undo. So, if I want to get t by itself, there are two options for the first step, but what would you do first? Divide by p. Can you do that? How many of you would have distributed p first? Can you do that? Yes, so both options are great. So I'm going to go ahead and divide by p, but distributing would work great also. Questions so far? Okay, now what? Almost. I like subtracting. Why would you subtract 1 instead of RT? Because I want to get t by itself, so I want to keep t on one side. But I like to subtract. Okay, very good. And then last step. Divide by r. And we got t by itself, right? I do want to show show you because several of you said you would have distributed first what it would look like if you did. Here first. I didn't really do anything, I just left it as a complex here. So the whole goal was to get T by itself, and we did it. It's complex looking, and you could get common denominators and simplify it, but for now, my goal for today is just that you learn how to do it. The order that I'm going to show you is just those of you who would have distributed first, what it would look like. Because that's a perfectly viable option, no problem with distributing first. And you would get P plus PRT. Does everyone agree? I'm going to multiply it by P. Does that make sense? P times 1 and then P times RT. P times 1, and what's anything times 1? Yeah, like 3 times 1 is just 3. You could put times 1 there and it would be incorrect. Now let's subtract P. You notice we are just practicing undoing things, right? So everyone kind of see that? And then what would the last step be? Divide by PR. First glance, it doesn't look like these are the same answer, but they are. You would have to get a common denominator over there to see that, but they are the same thing. Those are two options for getting T bites. They are both wonderful. I probably prefer the one in red just because it turns out with a prettier answer, but they both work. Okay, let's look at the next one. The next one is solve for X. So solve for X, the one on the right. What would we do first? Distribute the 2, and I would definitely do that on this one. Otherwise, you get fractions involved. Not that fractions are the end of the world, but you probably would prefer not to have them. And now what? Okay, add 2b. What's our game plan? Before I start doing it, what am I trying to get by itself? And so to get x by itself, do you agree all the x's need to be on the same side, right? Now, it doesn't mean adding 2b's wrong, but then you would end up having to subtract a 5c over, which is perfectly fine. But make sure we kind of know our game plan. We do want to get all the x's on the same side. Do we still want to add the 2b? We still like that? We would. Okay, minus C4x would be a little more efficient. Those are not quite like terms, so I can't put them together yet. This is the step most people forget and don't know how to do. So this is the step you might want to star in your notes. To get that x by itself, I'm going to have to factor it out so that I can divide by the other pieces. Since there's an x in both pieces, I'm going to factor that out. So once you get all the x's on the same side, if it's only a plain x, which these problems will be, no squares or cubes or anything, you'll factor that x out. And then what's the last step to get x by itself? putting it by itself. So what's with the x? The 5c minus 4, so that's what I'm going to divide by. Any questions about that? One on the left. Also solving for x. So this is another one of the tough ones because there's two different pieces with x's in them. So again, what's my game plan? Before I start working, what am I going to try to do? Get x by itself. So I need them all on the same side, and then I want to try to isolate that x. So first, what am I going to do? Distribute the negative 2. So we don't run into that. And then I want to get all the x's on the same side. So how would I do that? Add what? Add 2x? How about that? You can do more than one thing in one step. For right now, I'm just going to do one thing at a time just because notes take time. You can add multiple things at the same time if you wish. So I get 8t equals 3xt plus 2x plus y. And then I need to subtract the y to get it out of the way. So I want an x is on the same side, but I want it doesn't have an x out of the way. Remember, you can only combine them if they're like terms. So 8t minus y is just 8t minus y. Okay. Now here's the tricky step. Does anyone remember what to do here? Factor out an x so that I can divide by everything. So that's kind of a new piece. Probably everything else you all knew how to do. Again, another big ACT skill. ACT will make you rearrange equations. And last step, divide by 3t plus 2. So we're factoring out a greatest common factor, except instead of a greatest common factor, we're just taking the x. Any questions about that? Your homework is due Wednesday because I won't be here tomorrow. So we're not grading it tomorrow. And tomorrow is a work day. So you can use tomorrow to work on this all day tomorrow if you want. That's up to you. For some of you, you will finish this with a little extra time. If you wanted to work on what I'm teaching on Wednesday, you can. But remember, I'm teaching this on Wednesdays. So if you come to us and problems on this one that you can't do, don't stress about it. And just negate it. Okay, so everyone understand tomorrow, you get to work on this all day tomorrow, you're benefiting because I'm going to be out tomorrow. So you have all day tomorrow in class, do something tonight if you want, and then this part is due on Thursday. I will teach it on Wednesday. So you don't have to touch it at all if you don't want to, but if you want to, if you get finished in your board. Make sure you bring something. If you feel like you're going to finish the